Hey guys, welcome to GER Hub Mathematics and Statistics lessons. In today's video, I will be talking about the product rule of differentiation, okay? The product rule of differentiation. We are going to be proving the product rule of differentiation and also using an example to illustrate the product rule of differentiation. If you haven't subscribed to this channel, please kindly subscribe to the channel now by clicking the subscription button below and endeavor to please turn on your notification bell. Also like, share, and make your good comments on our video, and I'll be seeing you in this class. So welcome back. We are going to be showing in this particular video that if y is equal to a product of two functions u and v, with y, u and v being dependent on the same independent variable, then dy dx will be equal to v du dx plus u dv dx. Now I would want you to refer to my video I made on the first principle of differentiation. That is the short I made on the first principle of differentiation, and I'm going to be making a detailed video, not a short, on the first principle of differentiation. I want you to watch out for that video. It will help you understand what is being done here if you don't get it through the short. Okay, so let's begin. Now the first thing I'm going to do is this. Now let's see. So if I'm given a function y equals u times v, take note, I'm going to put it here. Y is dependent on x, meaning that y is equal to f of x, but the same y, which is equal to f of x, is a product of two functions. That is, f of x can be written as a product of two functions, u of x multiplying v of x. Okay, so when you see me write y equals u times v, I'm actually referring to y equals u of x times v of x. So f of x here can be decomposed into a product of two functions that make y. Okay, so this means that y, u, and v are all dependent on the same independent variable x. Now what we want to show is that if y is equal to a product of these two functions that are also dependent on x, then the y dx will give us what we stated earlier on. So to help us prove this to be true, we are going to be using the first principle of differentiation we had talked about earlier. So this is where I'm going to start with. I'm going to write y equals u v. Okay, now if an increment, an infinitesimal change must occur in y, then this must have come from an infinitesimal change in u. Okay, so you end up having delta u, okay, times v plus delta v. Now this is because an increment in y can only come when there's an increment, an infinitesimal increment in u and an infinitesimal increment in v. Okay, now the next thing I'm going to do is to make my y, delta y, the subject of formula, and that will give me u plus change in u in bracket times v plus change in v in bracket minus what? Minus y. Okay, so I have simply made delta y the subject of formula. Now if you proceed, delta y will be equal to u plus change in u in bracket v plus change in v minus what y is. Remember, y is given to be u times v, so I'm going to use u times v to replace y here, and you're going to have u times v here. Okay, so that is the first step I'm going to take. Now if you move on from this, let us go to the next step. The next step will be to write out expand. I'm going to expand that function. So u times v would give me uv, u times let me put this here so that you can actually see what I'm doing. So u times v gives you uv. U would multiply change in v to give you u plus change in v, and as uv plus u times change in v, then change in u would multiply v to give you v in bracket change in u, then change in u will multiply change in v to give you plus change in u in bracket change in v, then we are going to bring this in, minus uv. Now clearly you would see that uv can cancel minus uv, and that goes. So uv minus uv is 0. So we are left with change in y is equal to, we are now left with this, u in bracket change in v plus v in bracket change in u plus change in u times change in v. Okay, so that's what we'll be left with. Now the next step to take would be to get our gradient function. Okay, remember what we said in first principle of differentiation. The next step would be to obtain your gradient function. Now I'm going to obtain my gradient function by dividing this result we've obtained lastly by change in x. So the next thing I'm going to do here is to divide change in y by change in x, and that will mean dividing each term here in the last result by change in x. So change in u all over change in x plus change in u, change in v all over change in x. Now take note, one way to write out this is to write change in v all over change in x plus v change in u all over change in x. Now since product is commutative, I could decide to take out this change in u and write this change in v all over change in x. Okay, so this will give me my gradient function. Now the next and final step to take is to obtain the derivative itself. Remember from our discussion on first principle of differentiation, we had said that the derivative of a function is obtained by taking the limiting value of its gradient function as the change, the infinitesimal change in the independent variable tends to 0. So what we are going to do here now is to obtain the y, the x. For us to obtain the y, the x, we must recall that the y dx is the limiting value as change in x tends to 0 of whatsoever our gradient function change in y over change in x is. Now what have we obtained our gradient function to be? We have obtained it to be this. Okay, we've obtained it to be the last expression here. So what we are going to do, take note, will be to take the limit of each of these sums, or each of these terms in the sum rather. Now what you should know is that since we are taking the limit as change in x tends to 0, everything that is not changing x is seen to be a constant by this limit. Okay, so it means that u would come out in the first term, and I'll be taking the limit as change in x tends to 0 of change in v all over change in x, plus the next term will be v coming out with me taking the limit as change in x tends to 0 of change in u all over change in x. Okay, and that will be added to taking the limit as change in x tends to 0, taking the limit as change in x tends to 0 of change in u, change in v all over change in x. Okay, now the confusion here that you may experience is what is really going on with this. You may understand this one, that u has to come out because it is seen as a constant by the limit, v has to come out because it is seen as a constant by the limit. But for this one, change in u can't come out because it is affected. Take note, as change in x tends to 0, remember the function is y equals uv, meaning that u, v and y are all dependent on x. So what it means is that as change in x tends to 0, change in u also tends to 0, so also does change in v tend to 0. So in this case, u came out because it is seen as a constant by this limit, v came out because it is seen as a constant by this limit. But in this case, u, change in u can't come out because it is not a constant relative to the limit being taken. Change in v all over change in x is now to be addressed. So the limit of a product is a product of the limit. So what is going to happen here is you making a choice. Now it is either, if you take your gradient function to be change in v all over change in x here, then it has to be change in u outside. If you take your gradient function to be change in v here, then this has to be change in u all over change in x. Okay, so your gradient function, when it is change in u all over change in x, would mean change in v stays here. And if your gradient function is changing v all over changing x, then changing u has to stay here. So you have to decide which one. But whichever one you choose, the result ultimately leads to the same thing. So what it means is this. Now take note, as changing x tends to 0, this gradient function in v becomes dv dx. So dy dx can now be written finally as u times the limit as changing x tends to 0 of changing v all over changing x. As changing x tends to 0, this particular gradient function becomes the derivative of v with respect to x. As changing x tends to 0, you have v here multiplying ultimately du dx. So this becomes du dx. But in this case, if you want to take the limit of this product, the limit of this product will be the limit of changing u times the limit of changing v all over changing x. And take note, in this case, changing v all over changing x will be seen to be the gradient function, meaning that the limit of this, although it will give you dv dx, when it multiplies the limit of this, which will give you 0, it will be 0 times dv dx, and that will give you 0. Okay? Now, even if you are taking it to be du dx multiplying changing v will tend to 0 as changing x tends to 0. Ultimately, it will be du dx times 0. So the result will ultimately give you 0. And that means when you summarize your result, that your final answer will be dy dx equals u dv dx plus v du dx. Now, this particular law or principle is called the product rule of differentiation. Now, I'm going to show you with one example how to use this. Now, when do you use this particular rule of differentiation? Use this particular rule of differentiation when you are given a function that is expressed as a product of two or more functions, okay? Use this particular principle when you can summarize a function as a product of two independent functions. So let's consider this example. Let's consider this example on how to use this. Now, let's assume that you are asked to find the derivative of y with respect to x for this function x squared minus 1 in bracket 2x raised to the power 3 plus 3x. Now, going by what we've done in my previous videos on first principle of differentiation, you will take note of the fact that taking derivative of each of these terms is simple. So let's look at it. Now, what will dy dx be is what we want to answer here. Now, how are we going to go about it? The first thing I'm going to do in this particular problem is to let each of these particular component functions to be represented with u and v, just like you have in the formula. So I'm going to do this. I'm going to say let u be equal to x squared minus 1 and let v be equal to 2x cubed plus 3x. That's what I'm going to do. Now, once you let u equal to x squared minus 1 and v to be equal to 2x cubed plus 3x, then the next thing will be to obtain the u dx. So after doing this, obtain the u dx. Now, the u dx will be 2 times the coefficient of x squared, which is 1 clearly. 2 times 1 will give you 2. Then subtract 1 from the power. That will give you 2x raised to the power 1, because 2 minus 1 is 1. Then the derivative of a constant, take note, is 0. So this is what you are going to get when you differentiate u with respect to x. You are going to get 2x. Now, coming over to the v dx. When you differentiate v, this is 2x cubed. Remember, in that video I made on differentiation, a simple way to differentiate polynomial functions, all you have to do is to use the power to multiply the coefficient and then subtract 1 from the power. In this case, where we had 1, the derivative of a constant gives 0. Why is this so? If you notice that, you can actually put x raised to the power 0 as a product with minus 1. such that if you have x raised to power 0 there, the reason why it is not showing is because the power is 0 clearly. If you have x raised to power 0, 0 will multiply minus 1 to give you 0. Okay, and when you subtract 1 from 0, it gives you minus 1. It doesn't really matter, it all amounts to 0, so the derivative of a constant will give you 0. Now in this case, you have 3 times 2 giving you 6x, subtract 1 from 3, the power, it will give you 2. Now for this case, the power clearly here is 1, so 1 times 3 will give you 3, and 1 minus 1, when you subtract 1 from the power 1, you end up having 0. X raised to power 0 will give you 1. So 1 times 3 is 3. Now what we've done is that we've obtained the u dx, and we've also obtained the v dx. At this point in time, we would now write the y dx equals, state what we got earlier, v du dx plus u the v dx. Okay, so this is the product rule. And what's our v? We are going to bring it here. 2x cubed plus 3x is our v. What is our du dx? It's 2x. What is our u? Our u was given to be x squared plus 1, so we'll bring it here, x squared plus 1. And what is our dv dx? Our dv dx is obtained to be 6x squared plus 3. And this is the result. So when you differentiate the function we've been given, this is what you are going to obtain. Until some other time, please don't forget to like, share, and subscribe to this channel. Please also give us your useful comments. I want to see your comments in the comment section. I'll see you in my next video. Thank you.